All right, hey guys. So today we're going to be looking at two new types within Solidity. We're going to be looking at the mapping type and also structs as well. So we'll start off with mappings. Now, what a mapping basically is it looks like this here. So it basically maps what's called a key type onto a value type. So for our example, we're going to have an address as a key type, and that's going to be mapped onto a value type, which is going to be a uint. So the way that I like to think of a mapping is it's kind of like an infinitely long array, and yeah, it's got your key type and it maps that to a value type. So let's get a bit more into it now. So this is it's essentially a variable, so we declare it the same way. We'll call it public and we'll say balance sent. So this is what I want this to be, is I want this to show when we give this balance sent variable name an address, when we tell it which specific address, it will then output a uint, an unsigned integer, and that's going to represent the balance that has been sent. So let's make a function. This is going to be our send to contract function. And it's just going to be a public payable function because we want to be able to pay to it. And what I'm going to say is I'm going to say the balance sent of the message.sender. So whoever sends money to the contract, yeah, that there is the address. Message.sender is an address type. That there's our key value, and that there is going to equal the message.value. So this is the address being mapped onto the uint. Now, if we deploy this quickly, and I'll show you how the whole thing's working now. So if we deploy it, okay, so we've got the send to contract function, we've got the balance sent mapping type. So if I go onto this account and I send 1 Ethereum, so from 97.99, send 96.99, copy this address and paste it in, the balance sent will be one Ethereum. Now, if we go over to another address and copy this one here, where I haven't actually sent any money to the contract yet, it's going to come up as 0. But if I now send money to the contract, let's say 2 Ether, oops, I've just deployed a new contract. Anyway, yeah, so if we then go on to do another one, for example, right now, check the balance sent, it's going to be 0. Send 1 Ether to the contract. Balance sent has now gone up to 1 million. So this is pretty good because we've now basically got loads of information about any given address, and we can gain something from it. So if we now make a withdrawal function, so where we withdraw from the contract, here I'm going to take, it's going to have two types. So it's going to have an address, which we'll call from, and then it's going to have an address to, but this has got to be payable, remember, because we're going to be paying it to this account. So this is going to be a public function, and what I'm going to say is that we're going to be transferring the balance sent from the from address. So whatever balance sent has been set there, and then after that we're going to send the balance set of from, and be setting that equal to 0, just so you can't repeat, so you can't send the same money twice. So this here is basically, yeah, we're transferring to this address, which we've said is payable. We're transferring to that the amount that this address has sent, and that there gets saved in this mapping here. So we access the balance sent using square brackets, and we enter the specific address we're talking about. So if we run this here now, deploy. Okay, so we're gonna go send it from this top account. We're gonna send 2 Ethereum. We're on 96, so we'll go to 94. As you can see, if we type up in here how much has been sent, it will be 2 million, or 2 however many. Okay, then when we press withdraw, we're going to be withdrawing it from this account that we sent it from and put it in here. Boom. Now this here should go up to 102,999, and it does. And if we then want to check the balance sent from the original address, it's been set back to 0, which is what this final line of code here is. So that there's mappings. Now we're going to go on to structs, which are a bit more confusing, and mappings integrate into them really nicely as well. So we'll go into that now. All right, so now we're going to go into structs. So I have already have some sort of layout already here. So this is the syntax for structs. We go struct, call that keyword, give the name of the struct. It's conventional to capitalize the first letter. And then basically what a struct is it's a type which holds more types within it. So in this payment details struct, it's got 2 types. It's got 2 unsigned integers, one being the amount and one being the time. And so this is just going to be like the amount sent by the sender and the time at which that was done. Now there's also, we've got this struct which takes a uint, so the transaction number, and this is going to be sort of a log. So for example, transaction number 1, transaction number 2, 3, 4, and so on. And then we've got this mapping which maps a uint, so maps an unsigned integer, which will be the transaction number. And that maps it onto this payment details struct. So depending on which transaction number we give this payment details mapping, that there will then in turn give us which payment details we're talking about. So that's why we've got this uint transaction number within it, because every time we execute a function, we'll then say transaction number plus plus, increase it, and then that means for the following one we've got a new transaction number for the new payment details. Now to access this stuff, finally we've got this final mapping which maps an address to this payments struct, which then in turn maps the payment details to these payment details here. So to access all of these properties, first of all we go into the address payments. Now here we've got to enter in an address, so address 1, whatever that one there is, and then this here takes us into these properties. So now we're going to have the properties of transaction number, or we're going to have the properties of payment details. Now, of course, for payment details, we then need to enter a uint. So that would be, for example, 0 or 1 or 2 or so on. And depending on which uint we enter, then depends on what payment details we get. So after that, we then have access to the amount, or we have access to the time. And that's basically how this kind of filing system works. It's similar to objects and arrays. But yeah, so we've got that out of the way. Now let's get into actual coding. So we've got this send to contract function. And this here is where we're going to start saving our information into payment details. So first and foremost, we're going to create a new variable, and it's going to be a payment details variable of the type payment details. It needs to be accessed from the memory because it's a struct that we've created ourselves, and we'll just call it payment. Now this is going to be equal to payment details and then brackets, and inside the brackets the arguments that we take are first of all the amount and second of all the time. So the amount is message.value, and the time, the way we do the current time is block.timestamp. That's it. So that there gives us the current time at which it's sent. So that there puts us in a nice format now. Now we're going to be entering that payment into the payment details. So for that we want to go address payments. The address we're using is the message.sender address. So whoever sends the message, it's going to be their address. Then it's going to be payment details. Now, like I said, this then maps on a uint to something else. So we're going to be needing to refer to the transaction number. So just before this, I'm going to be creating a new variable, which is a uint, and it's going to be the transaction number variable. And we're going to set that equal to address payments message.sender.transaction number. So this here this here just gives us a number. It's going to give us 0 to begin with because we've set it equal to 0. And then here we can just enter transaction number, and we're going to be setting this equal to payment. So now payment obviously maps. Payment is just this here. So now within transaction number 0 of payment details, we've got a uint of an amount of the message value and a time of the block timestamp. It is quite confusing, all of this. The best way to understand it is really just by having a fiddle with it yourself. That's how I did it, and now I understand it. I got pretty quick, understood it pretty quickly. But yeah, you just got to have a fiddle with it yourself. That's what I'd recommend doing. Okay, and finally will be incorrect. No, we won't do that quite yet. We'll do that when we send it. Okay, so this is all now fine and dandy. Now we're going to do the withdraw function. So we'll say this here takes an address which is from, and it's going to take a payable address, and we'll just call that 2. So we're going to be entering 2 arguments to this public function. Okay, so we'll say that _2 dot transfer. Now the amount we want to transfer is the amount inside here. So it's going to be address payments of the from address. So _from, and then it's going to be the payment details. Now we want whichever transaction number it's currently on. So again, we'll create a new variable, or actually what we could do is straight away just do that, because this here gives us a number. But to be fair, I prefer creating a new variable just because it's a bit neater and more concise. So we'll call the transaction number there, and we'll make that equals transaction number, and then we're sending the value, the amount of that. So before we saved the message value as the amount, now we're going to be sending the amount to 2. So done that. Now what we want to do is we then want to set this address, the amount in there. We'll set the amount into 0 so we don't send the same money twice. And also we then want to increase the transaction number once this has been done. So to do that, we'll go address payments _from, and the transaction number and goes increases. So it will start off as transaction number 0. Finally, when the transaction's sent, it then becomes transaction 1, so that for the next transaction we can have our own new payment details, because we'll send a different amount at a different time. So let's deploy this contract. Over here, message.value. That's meant to be a comma. Okay, so just change a few things. We changed that from message, because obviously we copy and pasted it, so it was message sender. We've changed that to be the _from address. There was a little typo here. I wrote payments details. It's payment detail, and we don't actually need to set the thing from 0, because by adding it on we then go on to the next one. So let's compile this. We'll run it and let's see it in action. So if we deploy the contract, as you can see, I've got this address here. So I'm going to send 1 Ethereum to the address, send to contract. Now if we check how much we've now sent, that gives us a transaction number. So yeah, we're on transaction number 0. We have to make another variable to go further into it. Whatever. So the transaction number 0. Okay, so now we've sent 1 Ethereum to the contract. So let's get that from somewhere to somewhere else. So we should get an extra 1 Ethereum here. There we go, 102. And now if we check the transaction number, it's increased by 1. So if we were to transact it again, of course, there's 0 in transaction number 1. We don't have, this amount is equal to 0. So if we press transact, as you can see, nothing more comes to the account. But yeah, there's it for mappings and structs. Like I said, I think the best way to practice these is literally just typing it yourself, and just having a fiddle around. For example, change it from message sender to numbers and see what goes on. But yeah, I hope you learned something from this, and I'll see you guys in the next episode.